All right, so section 3, last section, at least for a video. I think there's one more after this that combine things. But this one is dealing with comparing two means of independent samples. This one's maybe a little bit more straightforward. So a study was conducted to determine if the effectiveness of a certain treatment, a group of 102 patients were randomly divided into an experimental group and a control group, and then we want to compare the two means. So they give us some results that we'll look at. We've got a sample size of 41, a mean of 17.5, and a sample standard deviation of 9.9. Then we have these control. There were 61 in it, had a mean of 13.3 and a standard deviation of 8.2. So this is talking about their improvement. But the first thing, test whether the experimental group experienced a larger mean. So when we look at this, my experimental one, that was my group 1, right, my experimental. I want to see if my mean 1 is larger than my mean 2, my control. So we have to be very careful when selecting these. The first is that they are equal to each other. The means are equal to each other. And if mean 1, group 1 is my experimental, I want to see if it's greater than, if the mean is greater than. So I will check that. Find the p-value. So now I'll go to StatCrunch. And again, we're going to do a t-stat. This time we're doing two samples for independent, paired is for dependent means. Two samples for independent means. And we have a summary of the data. So now our experimental group, the sample mean was 17.5. The standard deviation was 9.9. And the sample size was 41. For the second mean, it was 13.3, standard deviation of 8.2, and a sample size of 61. This is something that we are going to uncheck. Pooled variances. There is a section in the book that talks about pooled variances and when to use them, and that's assuming that the population's standard deviations are equivalent to each other. They tell us that we are not using this, and so we're not going to use it. So let's go back to our data, but we have to uncheck that box. Now we said that the difference between them, the null, was that it equals 0, and this one would be that it's greater than. We said greater than. Let's look back at, see, they're written a little differently. If I subtract m2 to the other side, I would have m1 minus m2 is greater than 0, and that's what it has in StatCrunch. m1 minus m2 is greater than 0. As long as we are consistent with our equal signs and inequalities, we should be good. So we uncheck our pooled variances and we make sure that we keep our inequalities or not equals to the same. So we get a p-value of 0.0138. 0.0138. 138 would be 4 rounded to 3 decimal places. We will continue. So do I reject or fail to reject? It told me that alpha, my level of significance, is 0.05. My p-value is lower than that, so if the p is low, the hoe gotta go. We reject the null hypothesis. There is sufficient evidence. So we are choosing this one. Let's see what else they got for us. Make a confidence interval for this one. So again, I'm going to go back to my data. I'll just edit this. And now I'm just going to click on a confidence interval. Right, so I have all my data in there. And let's check out our level of confidence. 95% confidence. That's what we had. Let's go back to here. 95% confidence interval. Let's compute. And we get a lower limit of 0.4768 and 7.9232. 2, when we input these values, we get 0.47 to 2 decimal places, so 0.48 and 7.92. Now, do you notice what's not in here? I don't see 0 in here, like the difference between them. Is it 0? We said no, we reject that the difference is not equal to 0. And in here, this also says reject because 0 is not in here, right? So we are 95% confidence that the difference of the means is in the interval. We are 95% confident that the difference between randomly selected individuals will be in the intervals. So again, we're making an inference about a mean or the difference of the means. And so we'll pick that one. So this is the ideas for section 3, independent samples.